All right. So, last time we were talking about sum of arithmetic sequences, right? Our arithmetic sequences have a common difference. It's the same value being added or subtracted to each consecutive term as we work through our lesson. So this actually has a math name. This has a fancy math name. So when we talk about the sum of arithmetic sequences, the fancy math name for that is also known as an arithmetic series. There you go, fancy word for you right there. Series. So an arithmetic sequence is a list of numbers that have a common value being added or subtracted to create the next term in the list. An arithmetic series is a sum of some of those numbers. Okay, got it? Okay. All right, now, let me just remind you what we did yesterday. We had our super stairs, or was it yesterday? Yeah, it was yesterday, huh? We had our super stairs example, right? He was going up and down the stairs, and then he went up one and down, went up two and down two, and up three and down three, and we were calculating how many total steps he made, and we kind of figured it out, right? We kind of figured it out that we could write it in this sort of generic formula where if we knew the number of terms that we wanted to add together, we could break that into pairs, right? So if we wanted to sum the first 8 terms in a sequence, we could break that into pairs. And then we could take the first term and the last term, add those together, and then run it through that formula. And that would give us the answer that we were looking for. So when we added these all up by hand like this, we came up with 72 steps. And when we plugged it into our formula here, we also came up with 72 as well. Okay? Everybody good so far with what we talked about? Okay. So now, let's get into a little bit of math lingo. All right. I'm just going to put up here lesson 8 continued since we're working here. Yeah, I'm on a new page, so you can go to the back or new paper, however you want to do it. Okay. So, first thing we're going to talk about today is something called summation. Summation notation. Yeah, look at that. I'm a poet and I didn't even know it. Summation notation. Okay? All right, and here's what a summation notation does for us. It finds summation notation. It finds the arithmetic series. Okay? So what summation notation does for us is it finds the arithmetic series. All right, now, it's going to look a little weird. Okay, I want you to, let's skip like 1, 2, 3 spaces. Okay, so let's skip like 3 spaces here, and this is what I'm going to have you draw. Actually, yeah, no, actually 2 spaces is fine. We'll draw on the line after 2 spaces. 2, 3, whatever. Okay, you ready? Here we go. So you're going to do what's called a Greek capital S is a sigma, and it goes like this. Straight down, boom, like that. Sigma. That's a Greek capital S. Sigma. Okay? It's like a bent E. Okay? It's like a bent E. What's that? Do you have to take up 2 lines with it? Yes. Take up 2 lines with it. Take up 2 lines with it because there's some information that we need to write around the sigma. All right. So, on the top of the sigma, I want you to write an N. On the bottom of the sigma, I want you to write a K equals 1.
I am K. Oh my gosh.
All right. Now, we're going to write this right here.
Sigma.
What is this?
S-O-N.
Yeah, what is it?
Oh my sigma.
No.
Is it S?
No.
There's some formula.
It's the that's some formula, right? Exactly. I'm gonna kill that. I'm sorry. It's just gonna get so overused now. Okay, yeah. So this is the answer to the sum formula, right? And the answer to the sum formula comes from our sigma notation. Now, let me give you some notes on what these things are that you just wrote down here. This thing that you just wrote right here is our beginning term. The first term, a sub 1. And this right here is our ending term.
Wait, but why is the K now?
We'll talk about that.
Because sigma.
We'll talk about that. Now, there's one other part to the sigma that you need in here, and that's right in the middle. And so I'm going to put this in parentheses. This is the explicit rule or explicit formula. Wait, that sounds like a lesson we did. Mm-hmm.
No.
Power drill. This is your power drill rule. So on the sigma, you're going to indicate the beginning term of your series, the ending term of your series, and what is the rule that governs that series. What is the explicit rule? Remember, the explicit rule is the equation that we can use to find any term in the sequence. Hey, I want to find the 7th term, plug it to 7. Hey, I want to find the 13th term, plug it to 13. Hey, I want to find the 112th term, plug in 112. Right? The power drill. I don't want to have to go 7 to 8 to 9 to 10 to 11. I don't have to do that. I want to be able to just go from 7 to 113 by using my explicit formula. Remember that? That's what that was. Okay. All right. So let's use it, and then it will make more sense as we go along. So we're going to call this section Evaluating Summation Notation. Okay, evaluating summation notation. We're going to call this example 1. And again, I'm going to leave the line next to example 1 empty, so I'm going to start drawing my sigma right below that. And so I'm going to go,
Why is it called sigma?
because it's a sigma. That's what it is. It's a Greek letter. All right, now, I'm going to write it, but I'm going to say it in English language. I'm going to write it in math language, but I'm going to say it in English language, okay? So maybe you want to watch what I write, but listen to what I say. Okay, so watch what I write, but listen to what I say.
I'm still learning how to draw
Okay.
sigma.
So when I draw the sigma, I'm going to say, hey, I want you to find the arithmetic series of the first 7 terms of the sequence governed by the rule 3n plus 1.
I understand. It again.
I want you to find the arithmetic series for the first 7 terms of the sequence governed by the rule 3n plus 1. It's a question. This is a question right here. And I'm going to give it to you on a test just like this. And you're going to have to be able to understand what the heck I'm saying when I write that down.
Okay.
Because I'm going to ask you a question, and that's the question I'm going to ask you right there.
Wait, so what does the thing, I know K plus 1 is the beginning term, but what does that have to do with the, whole thing? Because you don't know the rest of this.
Well, let's finish the rest of it, and I'll show you.
You're impatient, is it? Situations because they K equal 4.
We'll get there. We'll get there. Okay. But right now, okay, so right now, just to be clear, we're talking about, I want you, let me phrase it a different way, because I said the first 7 terms, right? How about I say it this way? I want you to calculate the arithmetic series for term 1 through term 7 governed by the rule 3n plus 1. Okay, I could say it like that. That's the first 7 terms. All right, now, here's what we're going to do. When I ask you that question, you are now going to take that and you are going to translate it into what we call a closed formula that's going to look like this. Okay, Mr. Farkas, I can do that. The sum of the first 7 terms, or the sum of the 7 terms you're asking for, is equal to, well, it's 7 terms, right? 1, and then 2, and then 3, and then 4, and then 5, and then 6, and then 7. So it's a total of 7 terms. So it's 7 terms broken into pairs. And then I want the first term and the last term.
1.
Well, okay, so here's the deal. The first term in the explicit sequence, right? This is where we plug the term number in to get the sequence value. So if I want the first term, I plug in a 1 for n.
Right.
So 3 times 1 is, plus 1 is. Okay, so the first term in this sequence is 4. And our series ends where? 1 to what? 7. Okay, and what is the 7th term in this sequence? 22. How did you get that? You took 7 and plugged it in for n because this is the explicit formula. You plug the term number in and you get the sequence value. That's the power of the drill right there. See how this works? I don't even have to give you the sequence anymore. I can just give you this, and you can calculate any term value, and you can sum up those values by using your sum formula. Okay, so this is going to be 22. All right, let's keep going. So this is 7 divided by 2 times 26. Okay. I can cross cancel the 26 and the 2. Gives me 13. 7 times 13. 7 times 10 is 70. 7 times 3 is 21. 91. Okay, what we're saying is if I take the first 7 terms of the sequence, I should get 91. All right, now let's do a little translation here just so that you're clear. I'm going to box this in right here, okay? And I want you to swoop a little arrow down here because we're going to translate what's in that box right now, okay? And here's how we're going to translate it. In English language, it's going to say this. Find the arithmetic series of the first 7 terms of the sequence governed by the explicit rule 3n plus 1. Find the arithmetic series sum of the sequence numbers.
What?
It's the sum of the sequence values. That's the arithmetic series. So find the sum of the sequence values. The first 7 terms of the sequence governed by the explicit rule 3n plus 1. Okay, let's do this. Just for clarification. Let's write the sequence. I didn't give you the sequence, but let's write it. Where am I going to start?
4.
Yeah, 4, right? I'm going to start at 4. Okay. What's the next number in the sequence? Oh, wait, we don't know the common difference. But we do have the explicit formula. So what's the second number in the sequence? 7. Plug in a 2. 3 times 2 is 6 plus 1. 7. What's the third term in the sequence? What's the fourth term in the sequence? What's the common difference? 3. Did you see how I pulled that information from there? See, so by just giving you this right here, I can say, write me the sequence. I can say, tell me the common difference. I can say, find me the arithmetic series. Are you listening to all the questions I can ask you just by giving you that one piece of thing? Because I'm going to ask you all those questions, so make sure you know. Okay? What do you think?
I think I need practice.
Okay, we're going to do some practice today on that. So today, all of your practice questions are going to look like this. They're all going to be written in summation notation. You have to be able to interpret them into this to come up with this. Okay? That's what your practice questions are going to look like today. Let me give you a little twist. Let's give it a little spice. Let's heat it up just a wee bit.
No. No.
Who thinks they can tell me in good old plain English language what I'm asking for? Anybody want to tell me what you think I can ask for? Gray, you want to give me a shot? You think you know what I'm asking?
Find the arithmetic series of the first 9.
Close. If it were the first 9 terms, it'd be the first term and the second term and the third term and the fourth term and the fifth term and the sixth term. Where are we starting?
third.
Okay.
So the 6. I don't know.
Okay, but you're on the right track, right? I want to find the arithmetic series of terms 3 through 9.
Yeah.
So now I'm going to take my sequence and I'm going to chop terms 3 through 9. Okay, now let me give you a little helpful tip here. Okay, so I'm going to give you something to write down up top here. Okay, now that we're talking about this. So the number of terms being summed. What can't you see?
Wait,
I'm writing in the upper right.
oh,
The number of terms being summed
so confused.
can go like this. N minus k plus 1. Top limit minus bottom limit plus 1. That'll account for the actual counting of that bottom term, right? Think about it. If I want to go from 3 to 9, I want the third term, the fourth term, watch my fingers, the fifth term, the sixth term, the seventh term, the eighth term, the ninth term. How many terms is that? 7. What's 9 minus 3? 6. Plus 1 is 7 terms. That's how you figure out the term numbers, is the top number minus the bottom number, add 1. And the reason why we're adding 1 is because when we do subtraction, we're not counting the actual number we start with, right? Okay, so in this particular case, we got to find the third through the ninth terms, and we got to sum those up together. So let's see if we can translate that into something. All right, now we're not doing all 9 terms. We're doing the sum of 7 terms. So we would write that the sum of 7 terms, because that's how many terms we're doing, is equal to the number of terms in pairs. But this time, it's not going to be the first term and the last term, because we're not starting with the first term and last term. We're starting with the third term and the ninth term, right? Okay, in fact, let's write that down here. So here we're going to have the third term, and here we're going to have the ninth term, and this is still going to be a plus problem. So how do we figure out the third term? In the what? Put them in the what? The explicit rule, right? Okay, so third term goes in here. 9 plus 1 is 10, right? Okay, so I got 10. And then the ninth term? 3 times 9 is? Plus 1? 28. Okay? Yeah.
Why is it a 7
Because we're actually only summing 7 terms, not 9 terms. It's okay. It actually is kind of it's a challenging question.
Why did you do that? Because you found 1 through 7.
Because we found 1 through 7. That's why it's the same.
So you found 7 terms.
We're still doing 7 terms. We're just doing a different 7 terms. Instead of going 1 through 7, this time we're going 3 through 9. Sum's going to be different if we sum 3 through 9. Okay, so now I got 7 halves times 38. 38 divided by 2 is 19. 7 times 19, that's 70. And 63, 133? All right, 133. Yeah. Yeah, because I cut 38 in half to 19. And then you just do 7 times 10 and then 7 times 9 and add them together. Okay, so let's do this. Where does this summation problem begin? Okay, what is the third term? 10. Okay, this is the same sequence as we were doing before, right? Look, third term, yeah? Same explicit rule, right? Okay, so then what's the next term? 13, and then what?
16.
And then 16, right? And you know what? Since we're doing sums, let's just add these. How about we just add them? 16, and then we're going to add next. What? Good luck, boys. 19, and what are we going to add to that? No. 22. Okay, and then what comes next? And what comes after that? And do we any more? No, because that's the last term, right? That's the third, fourth, fifth, sixth, seventh, eighth, ninth term. There's 7 of them. So let's add those up.
No.
Okay, you got it added up? Take a calculator, add them all up. 10 plus 13 plus 16 plus 19 plus 22 plus 25 plus 28. Oh my goodness, it's 133. How did that happen? It's magic. Or it's math, one of the two. Sometimes it feels the same. Huh? Okay, so today you will see problems that look like this, starting at 1 and going to a term number. And sometimes you will see problems like this that start at other term numbers and end at different term numbers. And it's really all the same process, just understanding that you need to find the number of terms that you're summing, and then this is your beginning term and this is your ending term. So if it's beginning with 1 and ending with 7, then it's the first term and the 7th term. If it's beginning with the 3rd term and ending with the 9th term, then it's 3rd and 9th, like that. Okay? We good so far?
Yes.
All right. Now, I'm going to give you one more example of things that we're going to do with this, but you're not going to do anything with it today. But you are going to do stuff with it on Thursday when you come in, because I'm going to be gone. And so I want you to be able to take this to the next level. All right. So, yeah, let's do it. Okay, I'm going to go to the beginning of the next page. All right, here we go. So now, let's talk about writing summation notation. Okay, we're going to turn around and go the other direction on the sidewalk. No, we're going to turn around and walk the other direction. This time, we're going to start with the English language version, and you're going to have to go to Sigma. Exactly. All right, so you are going to write the following question in summation notation. And I'm going to have you write this all out so you recognize the language, so you know what you're being asked, right? Because it's important to know what question you're being asked. So you're going to write the following question in summation notation, and here's the question. Find the arithmetic series of the first 6 terms of the sequence 3, 8, 13, 18, and so on.
Oh, so we have to find.
Wait, hang on. I didn't ask you to find the arithmetic series. I asked you to write the question. Find the arithmetic series of the sequence 3, 8, 13, and 18. I want you to translate my question that I asked you right there into math language. That's what I'm asking you to do. I'm not asking you to find the sum of the first 6 terms. I'm asking you to rewrite the question in summation notation. Okay, well, let's do this. We know if we have to rewrite the question in summation notation, we're going to need a sigma notation. So I'm going to go like this. And then I'm going to need a k equals, and I'm going to actually, just so it's clear, I'm going to do some little highlight boxes here. So I need to fill in that space, I need to fill in that space, and I need to fill in that space. Those are the things that are needed in order to rewrite the question in summation notation. Would you guys understand that? You agree? Yeah? All right. The first 6 terms of the sequence. That means we're starting where? Where are we starting? First 6 terms. Okay, we're starting at 1. Where are we ending? 6. Okay, that was easy. First 6 terms. If I said terms 7 through 15, where would the 7 go? Top or bottom? And the 15? Okay, that's easy, right? All right. So now all we got to do is we got to come up with what is the explicit rule that governs this sequence right here. Give yourself a little squiggle. Give yourself a little arrow. All right, now here we go. This was our generic rule for finding the explicit formula. This is how we came up with the explicit formula. We started with this generic rule, which was we can find any term in a sequence if we take the first term and we add to it the common difference times the term number minus 1. Do you remember this? Yeah. Right? You should. Okay, all right, now let's plug in the numbers that we know from looking at our sequence up above. So if we want to find any term number in our sequence, what's the first term? Okay, so we can start with a 3. Do we know the common difference? Okay, so plus 5. Okay, and then this is going to be n minus 1. This is the, remember we called this the unsimplified explicit rule, right? Okay, and then we had to simplify it, right?
So when we write it in summation notation, we have to simplify it too.
Yes, in summation notation, it must be the simplified explicit formula. And I'm going to have you write it with the variable term first and the constant term last.
Wait, that's kind of crazy.
See how I did that? And then this goes here. Okay, so I asked you to I asked you to rewrite this question that I just pointed to here. I asked you to rewrite that question in summation notation. Your answer to that question looks like this when you type it into formative. There's a sigma in formative, and there's a place where you can edit the top and the bottom, and then type in the middle. That's not today, but that is coming on Thursday, and so you need to know how to be able to type that in. Okay, now when you click the button, the sigma button, it's already going to have stuff up here and down here. You just arrow up in there or click down in there with your mouse or your pen, and then you can edit it. You can change it to what you want. Okay? All right, now we're going to answer the question.
We have more writing?
Yeah. Now, answer the question you wrote. Yeah. Now answer the question. What was the question? This is the question right here. There it is. That's the question. Answer that question.
Did we not already have the answer?
No, we didn't do the answer. We wrote the question.
Wait, JK, don't.
We just wrote the question. We didn't come up with the answer. Now I want you to come up with the answer.
So the question, it's going to have like 2 parts. It's like 2-part answers. It's going to have that and then also.
Unless I split them into 2 separate questions, which I might do. So So the reason why I say that, Sophia, is because I need to emphasize that you need to know what I'm asking you, right? So if I'm asking you to rewrite the question and I give you some statement like this, rewrite that in summation notation, this is what I'm looking for here. If I say, actually find the arithmetic series, then what I'm looking for from you is something like this.
Oh, okay. Wait, I thought we were writing the... Dude! Okay.
Do you see what I'm doing? Now I'm answering the question that was asked right above. What's the 6th term in this one? Yeah, 28, right? 6 times 5 is 30 minus 2.
I'm covering it.
So then 3 times 31? 93?
Yeah.
Yes, ma'am.
What's your favorite number?
I don't really think I have a favorite number.
My
I
favorite
don't
number
know.
is 5.
My was
5?
3.
Yeah, I don't think I really have a favorite number. I didn't really have play sports, so I didn't have a number one, like
I don't
that
have
kind
a
of a
number
thing.
either,
So.
though.
Yeah, but like,
You seem like a
the whole,
7 guy.
yeah.
What's that?
You seem like a 7 guy.
Well, 7 is the perfect biblical number, so
Jaden, what's your favorite number?
Okay, let's just see if this worked.
5.
Let's take our series. So our series is 3 plus 8 plus 13 plus 18. That's 1, 2, 3. That's 4 terms. We want 6 terms, right? So what's the next one in the series? 3 plus 8 plus 13 plus 18 plus 23 plus 28. Let's finish first. Okay, so 3 plus 8 is 11.
It's 93.
13 plus 18 is 31. 23 plus 28 is 51.
I don't know.
11 plus 31 is 42. Plus 51 is 93.
Oh my
Wow,
God.
that's crazy.
K or S?
Okay, so let's just review before we go to practicing. Okay, you have learned 3 things today. You've learned what summation notation is. Then you've evaluated it starting at the first term. You've evaluated it starting at some other term. And then you have written a question in summation notation given to you in English language. And then used that question to then calculate an arithmetic series. This, not today. We won't practice that today. But you'll have it to look back on when we do practice it on Thursday. All right? Okay.